Okay, so we're going to look today at inverse linear functions. So we've been talking a lot about linear functions, straight lines. What we're going to look at today is how can we find the inverse or the opposite of that linear function that we're looking at. So the standards that we're looking at here, creating equations to represent the relationship between two quantities, which we've been doing, graphing those equations as a straight line on a graph, solving the equation. If we've got a function, we're going to take that function, find the inverse, and write an expression for that inverse. So that's our goal for today. So before we represented relations as tables, graphs, maps. Today we're going to find the inverse of a relation and the inverse of a function. So the first thing to understand is what is the difference between a relation and a function. So a quick review. A relation is any sort of relationship between x and y, okay, or it could be any quantity really. A relation is just a relationship between any two quantities. A function, on the other hand, is a specific type of relation where every x value goes with only one y value. Okay, so for example, let's say if we have the function y equals 2x, or sorry, x plus 2. Let's just take an easy one, x plus 2. Okay. If we plug in different values for x, we should be getting different y values. For example, if I say x is 2, okay, and I plug that into my function, then y is equal to x plus 2, or in this case 2 plus 2, so y is equal to 4. Okay. Every time I plug in 2, it'll give me 4, no matter what. Okay? That's what makes it a function. When I plug in a value for x, it gives me one and only one y value. If I plug in 2, it's going to give me 4 every time. It's not going to be negative 2 one time when I plug it in. 2 plus 2 is always going to be 4. So as a point, 2 here goes with 4. Right? If I chose a different value for x, let's say I chose 3, well, 3 plus 2 would be 5. That's a terrible 5, but we'll live with it. So 3 would be 5, because 3 plus 2 is 5. All right. So that's what makes it a function. A relation, if I plug in, if I give a x value of 2, one time it could be 4, okay? Another time it might be something different. 2 could be with 0, okay? So that's a relation, and this is a function down here. So this is a relation. Notice 2 is with 4 and 2 is with 0. Okay. In a function, 2 is with 4 and that's it. Okay. 3 is with 5 and you could keep going, plugging in different values for x. But 2 is always going to be with the same thing in a function, whereas a relation, it could give you different values. So that's just a quick review of the difference between functions and relations. Okay. Okay, so what we're going to look at today is inverse relation. So what is an inverse relation? So the key thing that we're looking at here is that if one relation contains the element, in this case, a, b, stands in place of x and y. Okay, so if we've got values x and y, the inverse of that relation is x and y switch places. That's literally all it is. And we take our x and our y values and we switch the locations of them. So if I look at a and b here in the example, a is made up of 4 points, -3, -16, -1, 4, 2, 14, 5, and 32. To create the inverse, all I'm going to do is switch the locations of x and y. So in this first point, x is -3, y is -16. To make the inverse, -16 becomes my x value, -3 becomes my y value. All I'm doing is switching the locations of each of those points for x and y. Okay? So -3 goes this way, and -16 is my new x value, okay? And I'm going to do that for each of the following points also. -1, 4 becomes 4, -1. 2, 14 becomes 14, 2. 5, 32 becomes 32, 5. All right, so let's take a look at an example. Find the inverse of each relation. So if I've got a set of points here, -3, 26, 2, 11, 6, -1, -1, 20. To find the inverse, we're just going to switch the location of those points in the ordered pair. Okay, so if I take x and y for my points, to find the inverse, just switch and make it y and then x. Okay. So for this example, so in this example here, take -3, 26, 2, 11, 6, -1, and just switch the locations for those x and y values. Okay, so -3, 26 becomes 26 and -3. 6, -1 becomes -1, 6. 2, 11 becomes 11, 2. And -120 becomes 20, then -1. So all we're doing is switching the locations of the x and y values. So the inverse of this relation here, -3, 26, 2, 11, 6, -1, -1, 20, is to switch those x and y values. So the inverse is 26, -3, 11, 2, -1, 6, and 20, -1. Same thing that we're looking at here, but instead of a set of points, what we've got is a table of x and y values. So what we want to do is write each of those coordinates as a set of ordered pairs. That'll allow us to switch the order for x and y. So we take -4 and -3, write it as a point. X is -4, y is -3. The inverse, I just switch the locations, so now x is -3 and y is -4. -2, 0 becomes 0, -2. 1, 4.5 becomes 4.5 and 1. 5, 10.5 becomes 10.5 and 5. So the inverse of this relation here as a set of points is a typo, it should be -3, -4, 4.51, 0, -2, and 10.55. So that's a typo there. That should actually be, let's write it in here. These should both be negative numbers, -3 and -4. All right, so go ahead and try one on your own. Find the inverse of 4, 8, -6, 6, 3, 3, and 0, -8. All right, so we've also dealt with graphs of linear functions. So in this case, what we've got here is a graph of a straight line. And they want us to create the inverse for this particular function. So what did we do on those previous examples? Well, what did we took the x and y coordinates and we just switched the locations of the x and the y values. So for this line, in order to create an inverse relation of this line, I need a set of points. So I can look at the graph and I see that there's a point here. Okay, there's a point here that we could use. There's a point down here, and so on. So I can take these sets of points, okay, and I can write them as x and y coordinates. So let's take a look at this point here. The one up at the top left is at -1. So if let me make a column, I'll make it easier. Take x and y and just list different points on the graph. So the first one we've got x is at -1. Y is up at +4. Okay. Next one, x is at 0. Y is at +2. X is at 1. Y is at 0. And I can keep going. 2. X is at 2. Oops. Y is at -2. And x is at 3. y is at negative 4. Okay. So each of these points I've just listed in a table. So in order to find the inverse, all I'm going to do is switch the location of x and y, okay, to create a new set of points. Okay. So why don't I write my inverse table over on this side here. Okay. So we're going to do the same thing, but now we're going to take the values that we had over here and we're going to write them as an inverse. So negative 1, 4 becomes 4 for x, negative 1 for y. 0, 2 becomes x is 2, y is 0. 1, 0 becomes 0, 1. 2, negative 2 becomes negative 2, positive 2. 3, negative 4 becomes negative 4, 3. Okay. So now I've got a new set of points that I can put on the graph. So for negative 1, I go over to x is 4 and y equals negative 1, and I put a point at 4 and negative 1. For 2, 0, I go to where x is 2 and y is 0, and I put a point there. 0, 1, same thing, put a point. Negative 2, positive 2, put a point there, and negative 4, positive 3. Okay. And what do you notice about this new set of points? Just like the original graph that we had, these sets of points are also in a straight line. They're just in a new location. They're the inverse of what we started with on our original line. So if I can connect these points with a straight line, we'll see how this goes. This is going to be a little bit of a curve, okay, but pretty straight. So the inverse of the line that we started with here, right? So what we did was we identified different points on the line, put them in a table, inverted them to create our inverse function, graphed the new set of points, and connected them with a line. And you can see a better graph that makes that more clear. Right? But notice all those points that we use are in the same location. And negative 1, 4 became 4, negative 1. 0, 2 became 2, 0. 3, negative 4 became negative 4, 3. So we graphed those sets of points and connected them with a line. Same thing here. So why don't we do the same thing that we started on the last problem? So first thing we want to do is identify some of the points on our line. So I've got points at, let's see, negative 1, 1, 2, negative 3. There's a point down there. 1, 0, and 3, 3. Okay, so if I take those 3 points and I put them in a table, okay, that'll let me be easier for me to invert them. So the first point was at x was negative 1, y was at negative 3, x is at 1 on my second point, y is 0, and the third point, x is 3, and y is 3. So what I want to do is create a new set of points to write the inverse. So I take the points that I had and I just switch them around. So negative 1, negative 3, x is now negative 3, y is negative 1. X is 0, y is positive 1. X is 3, y is 3. Notice for this last one, since x and y are the same value, when we switch them, the point is actually going to remain the same. So let's take a look at what that would look like on the graph. So let's put the points at negative 3, negative 1 is our first point. 0, 1, so x is 0, y is up at positive 1. And 3, 3. And again, notice, just because x and y were the same, when we switched them, it didn't switch the point. So 3, 3 is going to be included in both of our lines. So if I can connect these, let's see how this one comes out. Pretty good. Okay. So 3, 3 is included in both lines. even after we made the inverse. So again, we just identified some points on our original line, switched them to create the inverse function, and then graph those new points on the line. And again, same thing. Here's a better view of what that line looks like. Again, notice the same point at 3, 3, because 3, 3, even if we switch it, stays the same. So go ahead and try this one on your own. Take a look at the line, see if you identify some of the points on that line, and then create the inverse for that line, invert the points, and then create your new line. All right, so far what we've been talking about was inverse relations. What we're going to move to now is inverse functions. So instead of it being just a set of points, even though those last few examples were linear functions, we didn't have a rule to go along with it. And then really that's what a function is. It's a rule or an equation. And so we're going to be finding inverse functions, in this case finding an equation and finding the inverse of that equation. So there's 4 steps that we're going to follow to find the inverse function. And this right here is the notation for the inverse function. Function notation is this, f of x. This is saying the function of the variable x. Well, to write the inverse of this function, we use f and then an exponent of -1. So f to the negative first of x. And we just read this as the inverse function of x. So to start with, what we're going to do, we've got 4 steps here. The first step is to take the equation, and we're going to take away the function notation f of x, and we're going to replace it with the variable y. That's because fx and y are really the same thing. You'll see it written both ways, but they mean the same thing. So if we're talking about points on a graph, usually we call those x and y. But in function notation, instead of using a second variable, we just use, we use x, and then instead of a second variable, we call the y variable the function. Let me undo that. The function of x. Okay. So fx and y are literally the same thing, so we can switch them out. So that's what our first step is. We replace f of x with y. Okay. And then, just like we did on the previous examples, we switch the location of x and y. The only difference now is in this case, we've got an equation, so we're actually going to switch the variables x and y in the equation. Then we resolve the equation for y, and then the last step is to replace y with our new notation, f to the negative first power of x, or the inverse of x, in our new equation. And you'll see what that looks like here. All right, so the first example. Find the inverse function of f of x is equal to negative 3x plus 27. So this is our function. F of x is negative 3x plus 27. So our first step is to write the original equation. And instead of using f of x, we're going to replace f of x with the variable y. So y is equal to negative 3x plus 27. This just makes it easier for us to see what we're switching around. So what we do, we take the 2 variables x and y, and we just literally switch their locations in the equation. So instead of y equals negative 3x plus 27, when I switch x and y, it becomes x equals negative 3y plus 27. Okay. That's the only difference between these 2 equations. Just switch the location of x and y. Same thing we were doing with the inverse relations. Okay. Now I need to take this equation here, x equals negative 3y plus 27, and rearrange it, rewrite it, so that it's back as y equals something. So everything that's over here with y needs to be moved to the other side of the equation in order to find the inverse. Okay, so if I've got x equals negative 3y plus 27, my first step is to remove this 27 to the other side of the equation. So right now I'm adding 27. So if I want to take that away, I need to subtract 27 from here and from the other side of the equation. So it would look like this. We subtract 27 from both sides, so we've got Instead of x equals negative 3y plus 27, we've got x minus 27 equals negative 3y. We just took this 27 and moved it to the opposite side, so it became negative 27. Then the next step is to divide the entire equation by negative 3. I need to get y by itself. So right now I'm doing negative 3 times y. So I'm going to divide negative 3y by negative 3. That leaves me with y. The important thing to keep in mind is that when I divide by negative 3 on the other side, I'm dividing the entire thing by negative 3. So I'm dividing x by negative 3 as well as 27 by negative 3. Okay, when I divided the same thing over here. So you can see what it looks like. Okay. So negative 3 divided by negative 3 is just 1. So we've got y. Right? And then over here, negative x over 3 minus 27 divided by negative 3. So let's take a look at this. Negative x over 3. Negative x over 3. Now if I do 27 divided by negative 3, I get negative 9. And that's equal to my variable y. So all I did was simplify. 27 divided by negative 3 is negative 9. And over here, x over negative x over 3, you could leave it like this, or you could write this as negative 1 over 3 times x. Either way is correct. Right. So now we've got the equation negative x over 3 plus 9 is equal to y after we simplified. So then our final step is to say, instead of using y, we're going to use the inverse function of x. So we replace y with the inverse function of x. So the inverse of f of x, our original function, was negative 3x plus 27. The inverse of that is to do negative x over 3 plus 9. Let's take a look at another example. Find the inverse function f of x, inverse of the function f of x is equal to 5 over 4 times x minus 8. So again, we're going to follow the same 4 steps. Step 1, take the original equation, but instead of f of x, I'm going to replace that with y. So y equals 5 over 4 times x minus 8. Step 2, switch x and y in the equations. So y equals 5 over 4x minus 8 becomes x equals 5 over 4 times y minus 8. And now we need to take this equation and solve it again for y. So move everything over here with y so it's all by itself. All right, so step 1, add 8 to both sides. Since I'm taking away 8 from here, I need to put it back. I need to add 8 this side, add 8 to the other side. So x equals 5 over 4 y minus 8 becomes x plus 8 equals 5 over 4 times y. Now before we move on to the next part, just a quick review. What did we do on the last problem? When we had negative 3 times y, we divided by negative 3, right? So in this case, I'm doing 5 over 4 times y. So what am I going to do? I'm going to divide by 5 over 4. Okay. Now, dividing by a fraction gets a little messy. So when we divide fractions, remember what we do. We keep, we change, and we flip. Keep it, change it, flip it, right? So 5 over 4, do it up here. 5 over 4 divided by 5 over 4. If I do, my rules for dividing fractions becomes 5 over 4 times, and then I flip it, so it's 4 over 5, okay? So when we have a fraction, instead of dividing by that fraction, it's actually easier to multiply, just like we did over here, 5 over 4 times 4 over 5. So I'm going to take 5 over 4y, and I'm actually going to multiply by 4 over 5, because it's the same thing as dividing by 5 over 4. Okay. Which means on the other side, I'm also going to multiply this whole side by 4 over 5. So anytime you have a fraction as a coefficient, 5 over 4 times y, to cancel out that fraction, you multiply by the reciprocal. So multiply, keep it, change it, and flip it. So you're multiplying by the reciprocal on the other side. And so that cancels out the fraction on the side with the y value. So the other side is 4/5 times x plus 8 equals y. What we need to do now is actually distribute. Okay, so we're multiplying x plus 8 times 4/5. So we're actually going to multiply 4/5 times x and 4/5 times 8. And when we do that, we get 4/5 times x plus 4 times 8 is 32 over 5. So 4 over 5x plus 32 over 5 is y. My last step, replace y with the inverse function notation. So the inverse is 4/5 x plus 32 over 5. So if we started with our original function, 5 over 4x minus 8, the inverse of that function is 4/5 times x plus 8, or 4/5 x plus 32 over 5. Okay, so now what do we do with this information? So let's take a look at a word problem. Carter sells paper supplies and makes a base salary of $2,200 each month. He also earns 5% commission on his total sales. His total earnings, f of x, for a month in which he compiled x dollars in sales is f of x equals 2,200 plus 0.05x. So a couple of things as we move into this original equation here. So right now, x is equal to his sales, right? Sales for the month. So x is sales. F of x is equal to the amount of money that he earns based on those sales. So what we say is that his earnings are a function of the number of how much he sells. So earnings. So x is sales and f of x is earnings. So the function that they give us is that his earnings is equal to 2,200, which was how much he gets in his base salary, plus 0.05 times x. Now this 0.05, where did they get that from? Well, it's 5% of his total sales. So they changed 5% to a decimal. So 5% is 5 over 100, or 5/100ths times x. So we want to find the inverse of this function. So the function is 2,200 plus 0.05x. So step 1, write the equation. F of x equals 2,200 plus 0.05 times x. We're going to replace f of x with the variable y. So y equals 2,200 plus 0.05x. We switch the location of x and y in the equation. So x is now equal to 2,200 plus 0.05 y. And now we take this new equation and we resolve it so that it's back to y equals everything else. So step 1, we need to get rid of this 2,200 and move it to the other side. So it's right now it's positive, so I need to subtract it to the other side of the equation. So it becomes x minus 2,200 equals 0.05 times y. To get y by itself, I'm going to divide by 0.05 on both sides. Again, when we divide the whole thing, it's the same thing as dividing each part by it. Okay, so 0.05. So that cancels out, we're left with y. Now, at this point, we could simplify this fraction a little bit to make it easier for ourselves. So let's think back to what we just did with the problem before. When we divided, we had a fraction, right? So we said 5% they wrote it as a decimal. Well, 0.05 is 5 over 100. 5 hundredths, literally. So what were we multiplying by y here? As a decimal, it was 0.05. As a fraction, it is 5 over 100. So another way to think of this, when I'm dividing by 0.05, I'm dividing by 5 hundredths. Okay? So instead of saying dividing by 5 hundredths, we could actually say we're multiplying. So dividing by 5 hundredths. So if I divide by 5 over 100, that's actually the same as multiplying by the reciprocal, right? Times 100 over 5. Okay? So dividing by 500 is the same thing as multiplying by 100 over 5. Well, what is 100 divided by 5? 100 divided by 5 is 20. Okay? So 100 divided by 5 is 20. So what am I multiplying both sides by? If I divide by 5 hundredths, I'm actually multiplying by 20. So let's take this, instead of showing dividing by 0.05, we're actually going to take x minus 2,200 and multiply by 20. So that was just a long explanation of what's about to happen in the next step. I just wanted to show you those jumps because it can get a little confusing. Let me take this away. So that's how they end up with this equation here. So they multiplied x minus 2,200 by 20. So then again, the distributive property says I'm going to do 20 times x, 20x, minus 20 times 2,200 minus 44,000. And that's now equal to my inverse function. I replace the y value with the inverse function of x. So the inverse of the original equation, 2,200 plus 0.05x, is 20x minus 44,000. All right, same problem. Now we're on part B. What do x and the inverse of x represent? Okay. Well, if you look back at the original equation, originally x was equal to Carter's total sales for the month. Right? So x was sales. Oops. X was sales. And f of x was how much money he made based on those sales. Right? So that was his earnings. Well, in an inverse function, what do? We switch x and f of x, right? So now, instead of x being sales, the inverse becomes the sales, and x becomes his earnings for the month. Okay, so we're still dealing with the same two variables, right? We're still dealing with the two quantities, sales and earnings. It's just that in the inverse, x becomes the earnings, and the inverse of his earnings, oops, forgot the negative one. So the inverse of his earnings is now his sales. So all it does, the inverse just switches the location of the quantities that we're looking at. So originally x was sales and f of x was sales and f of x was his earnings. Right? In the inverse function, x becomes the earnings and f of x becomes the sales. So x is now his earnings and f of x, the inverse of x is his sales for the company. And the last part, using the inverse function. So if you were to take the original function here, where his earnings is equal to 2,200 plus 5% of his sales, okay, we could find his sales based on his total earnings. Right? In this case, his earnings are $3,450. So we would replace f of x with 3,450 and then solve the equation. Well, what we've done by finding the inverse function is we've created a shortcut. So using the inverse function, because remember, now the inverse function represents his sales, which is what we're looking for. So our new equation, which was right here, the inverse function of x, which is now his sales, is equal to 20 times x, his earnings, minus 44,000. So his sales for the month is now 20 times the amount of money he earned minus 44,000. So what have we done? By finding the inverse, we did all of the equation to rewrite it as sales equals the rest of the equation instead of saying earnings equals the equation with sales. So all we've done is we've created a shortcut to where now we can take this inverse function, plug in the amount of sales, or sorry, the amount of money he earned for X to figure out how much he sold for that month. So we take the inverse equation, 20x minus 44,000, except now I know that X is he made $3,450. So his total earnings were $3,450. I put that in for X. Multiply 20 times 3,450, that gives me 69,000 minus 44,000. Subtract, we get 25,000. So what does that tell me? It means that he had $25,000 in sales for the month. Because again, remember, the inverse function is now measuring the sales, and X is measuring how much he earned. So we've switched the location of X and Y in the equation. And in the inverse function, then we're finding the opposite of what we had in the original problem. So Carter had his total of $25,000 in total sales for the month if he made $3,450 in earnings. And one more problem for you guys to do. There's actually a typo in one of these questions. This is actually supposed to be x minus 40. So it's supposed to be x minus 40 divided by 65, if that makes a difference in solving the problem. Okay, so read the question, find the inverse function, which will allow you to find the answer to the problem. Okay, and that's it for the lesson on inverse functions. So hopefully it's a little clearer as to how to identify an inverse function, how to graph an inverse function, and how to find an equation and use it to solve a problem.